Welcome back for the next session, session 10. Today we'll be doing the exercise sums in 8.4. Before we actually begin, I want you to check your homework which was given in the last session. If A, B and C are interior angles of a triangle, then show that sine of B plus C by 2 is equal to cos of A by 2 we have to prove. Now we know that sine of any angle is equal to cos of its complement. So it is cos of 90 minus of B plus C by 2. You have to write it. Now we have to get the answer in terms of A. How do we get it? You know that in the triangle ABC, if A and BC are the interior angles, we know that angle A plus angle B plus angle C is equal to 180 degrees. That is, angle A plus angle B plus angle C is equal to 180 degrees. Therefore, we can write angle B plus C as 180 minus of angle A. So, if you do so, this B plus C can be written as 180 minus of angle A. So, then there is 1, 2 down, close the bracket. So, this is cos of 90 minus 180 by 2 within the bracket minus angle A by 2. Now, here 90 minus of 180 by 2, that is going to give you minus 90. When it comes out of the bracket, you will get cos of 90 minus of 90, and minus this also comes outside the bracket, minus and minus, that becomes plus A by 2. So these brackets automatically get cancelled. So you have to close by means of a single bracket. So you will get cos of A by 2. The answer is cos of A by 2. You have to finish like this. So write down the first sum. Express the trigonometric ratios sin A, secant A and tan A in terms of cot A. Now in the beginning itself I have told you that all the trigonometric ratios can be written one in terms of other. So in this particular sum we are going to write sin A, secant A and tan A in terms of cot A. So first thing, we have to make use of the identities. Okay. So the third identity what we learned that day, that is 1 plus cot square A is equal to cosecant square A. Now cosecant square A is 1 by sine square A. So from this ratio, we can get the sine square A is equal to 1 divided by 1 cot square A. 1 plus cot square A. Okay, have you understood this step? Cosecant is 1 by sine. So 1 by sine square A is equal to 1 plus cot square A means when we reciprocate, we will get sine square A is equal to 1 divided by 1 plus cot square A. Are you understanding? Therefore, sine A is equal to, you will get square root of 1 divided by 1 plus cot square A. So, we will get square root of 1 is obviously 1 only. So, 1 divided by 1 plus cot square A. So, we have got it in terms of cot only. I want you to check your answers. So, the next we have got secant A. For writing secant A in terms of cot, again we will be making use of the identity only. But this time we will be using 1 plus tan square A is equal to secant square A. So, we all know that tan is the reciprocal of cot. So, I am going to replace the tan square A as cot square A and equate this to secant square A. Therefore, if you simplify, you will get cot square A plus 1 divided by cot square A, that is equal to secant square A. Therefore, secant A is equal to square root of 1 plus cot square A divided by cot square A. Now cot square A comes out of the square root. Therefore, we get 1 plus square root of 1 plus cot square A divided by cot A. This is how you must finish the sum. Now It is 1 by tan A and tan A is 1 by cot. So we can rewrite tan A as 1 by cot A. Finish. Children, we will move on to the second sum. Write all other trigonometric ratios of angle A in terms of secant A. But just like how we did our first sum, this also we have to use the same method. By using the identities, we will be able to write one trigonometric ratio in terms of the other. So we will just try. First, let us try sin A. Sin A is equal to, we have to write in terms of secant. For that, we are taking the identity, first identity, sin square A plus cos square A equal to 1. So I am writing this as sin square A plus cos square A equal to 1. I know that cos is the reciprocal of secant. That's why I have adapted this. So sin square A is equal to 1 minus cos square A, which I can write this as 1 minus 1 by secant square A, which on simplification becomes secant square A minus 1 divided by secant square A. Therefore, if you take the square root, this becomes square root of secant square A minus 1 divided by secant A. So this is the first ratio. Now let us move on to the second one, cos A. Cos A is obviously 1 by secant A. So that is very easily written. Now the third one is, we have to write the tan in terms of secant. So for that we have to use the identity tan A. Okay, but tan square A plus 1 is equal to secant square A. Therefore, tan A is equal to secant square A minus 1 with taking the square root. You will be getting like this. So straight away we are writing from the identity. First we have got tan square A to be equal to secant square A minus 1. Therefore, tan A is equal to secant square A minus 1 with the square root. We have to finish like this. Next comes secant is already there. Now we have to go for cosecant A. So cosecant is obviously the reciprocal of sine. Sine we have got it to be secant square A minus 1 with the square root divided by secant A. Therefore, if you reciprocate it, it will become secant A divided by square root of secant square A minus 1. This is your cosecant A. Then the last ratio is cot A. How do we write cot A? Cot A, we all know it is 1 divided by tan A. Therefore, I just write this as cot A is equal to 1 divided by square root of secant square A minus 1. So that is how all the other trigonometric ratios are written in terms of secant A except secant. So that's how we must finish the sum. We'll take down the third sum. There are two subdivisions in it. The first one, sin squared 63 plus sin squared 27 degrees divided by cos squared 17 plus cos squared 73, we will work out now. Okay. Now, if you notice, 63 and 27 are complementary. 17 and 73 are also complementary. So, we have to apply your complementary relationship in this sum in order to solve it. Okay. So, this can be written as cos square of 90 degrees minus 63 degrees, and then sin square you should write as it is. You cannot make two changes for the same term. Now here we can write cos square of 17 or either sin cos square of 73. Any one we can change as complement. I will choose it to change here. So that becomes what? Sin square of 90 minus 17 plus cos square of 73 degrees. So if you rewrite this, this becomes what? Cos square of 90 minus 63 is 27 degrees plus sin square 27 degrees, and then here it is sin square of 90 minus 63 is 73 degrees plus cos square 73 degrees. Sin square plus cos square for the same angle is obviously 1. So you get the answer as 1 by 1, 1 is the answer. See, sine square of 73 plus cos square 73 is also 1. Cos square of 27 plus sine square of 27 is also 1. 1 by 1, the answer is 1. Okay. Now come back to the next second subdivision. In the second subdivision also 25 and 65 are both complements. So what I can do here, I can change any one here and any one here. So if I change it, I will write sine of 25 is equal to cos of 90 minus 25 cos of 65 degrees plus, here I can write cos of, I can do that. Cos of this can be replaced as sine of 90 minus 25 into sine 65. So if you write, you will get cos 65 into cos 65 plus sine 65 into sine 65. So this is cos square 65 plus sine square 65. Obviously the answer is 1. 1 is the answer. Children, now we are going to do the fourth sum, the first subdivision. It is 9 secant square A minus 9 tan square A. And after this, we will be doing the fourth subdivision. According to the order of difficulty, I thought 1 and 4 will have step-by-step increase in the order of difficulty. Therefore, I have chosen to do the first and the fourth sum. Once it is thorough, then we will take up the second and the third. Now, this is 9 you can take out. So, if you take that 9 common factor out, we will get secant square A minus tan square A. Now, this is obviously based on the identity. 1 plus tan square A is equal to secant square A. You push the tan square to the other side, you will get secant square A minus tan square A equal to 1. Therefore, this becomes 9 into 1. The answer is 9. The answer is 9. Okay. So, you tick against that option 9. Coming back to the fourth sum, we all know that 1 plus tan square A is nothing but secant square A. So, I am writing this as secant square A, and 1 plus cot square A is cosecant square A. Now, we know that secant square A is 1 by cos square A and cosecant square is 1 by sine square A. Therefore, the reciprocal we have to find out. What is the reciprocal? 1 by sine square A. Denominator's denominator will go to the numerator. If you do so, the sine square will go up and you will get sine square A by cos square A, which is equal to tan square A. This is the answer you have to get. Tick against that option, tan square A. Children, this sum also is slightly difficult, but it is very easy if you actually think and do. Okay. Now, here secant is given, tan A given, and sine A, 1 minus sine A. Now, secant and tan can be written as 1 by cos A plus sine A by cos A. Of course, the second factor is 1 minus sine A, we are writing like this. So, this is your first step. Cos A and cos A have the same denominator. Therefore, I am just writing this as 1 plus sine A. Now, this cannot be simplified easier than any of this method. Okay. Now, here 1 plus sine A into 1 minus sine A, the numerator factors can be multiplied. So, if you multiply the numerator factors, you will get 1 minus sine square A divided by cos A. Now, 1 minus sine square A is obviously cos square A divided by cos A. So, 1 power gets cancelled. So, we will get cos A as the answer. Take the second subdivision, children. So this is slightly, it is more difficult than all other sums, but still we can work it, nothing wrong. Now 1 plus tan theta plus secant theta into 1 plus cot theta minus cosecant theta. Now I can write this tan theta as sin theta by cos theta plus 1 by cos theta. Same thing I can do for this factor also. 1 plus cos theta divided by sin theta minus 1 by sin theta. I can do that. Now here the common denominator, I am taking this as cos theta. Therefore, on simplification, this becomes cos theta plus sin theta plus 1. And for the other side, it becomes sin theta plus cos theta minus 1 divided by sin theta. Now if you look at this, these two numerators follow a pattern. What is that pattern? It is cos theta plus sin theta and sin theta plus cos theta, here plus 1, there minus 1. They follow the pattern of a plus b into a minus b. Therefore, I can rewrite this as cos theta plus sin theta the whole square, and then here it is minus 1 divided by cos theta sin theta. So this is the pattern. But this can easily be expanded using a plus b the whole square. If you expand it, that is cos square theta plus sin square theta plus 2 sin theta cos theta minus 1 divided by cos theta sin theta as the common denominator. Here you may get this doubt. Cos theta plus theta sin theta, and here sin theta plus cos theta. After all, this is addition. Sin theta is positive, cos theta is positive, sin theta is positive, cos theta. Nothing wrong if you rewrite this as cos theta plus sin theta, or you can as well proceed with that itself. Both are the same. Okay. So cos square theta plus sin square theta is 1. Therefore, this plus 1 and minus 1 will get cancelled. So we will get only 2 sin theta cos theta alone. So I will write here 1 plus 2 sin theta cos theta minus 1 divided by sin theta cos theta. This and this will get cancelled. So you get 2 sin theta cos theta divided by sin theta cos theta. They both will get cancelled. Final answer, you are getting it as 2. Children, we have completed the first 4 sums in this exercise. The next few sums are only proving identities. So there I told you in the beginning itself, there are lot many identities that can be proved using the 3 fundamental identities. That is what you are going to see in the next sessions. Okay. But before that, you should first remember, whenever I use a formula, say the identity, here the formula is identity, sin square theta plus cos square theta equals 1 say. Now, very often, these identities can be used in so many ways. How do we use it? We can write sin square theta as 1 minus cos square. Wherever that is applicable, you have to use it. Similarly, cos square theta is 1 minus sin square. So that is also applicable in several times. So the same identity can be used in 3 different ways. One is the straight. Second one, in order to get the answer to our favor, we have to make some modifications and apply the identities. Then only you will get the answers correctly. Now, the second identity you take, 1 plus tan square theta equal to secant square theta. Now, this identity, how does it modify? 1 is equal to secant square theta minus tan square theta by taking tan square to the other side. Now, another type of application is secant square theta comes to this side, LHS. So if that gets written here, you will get 1 minus secant square theta equal to minus tan square theta. So this way also it will be used at some places. So the same identity we have to use in 3 different ways. So secant square minus tan square gives you 1. That is one type of application. And 1 minus secant square theta. Secant comes this side and tan goes to the other side. You will get 1 minus secant square theta equal to minus of tan square theta. Now you tell me for the third identity, 1 plus cot square theta equal to cosecant square theta. You can write this as 1 minus cosecant square theta is equal to minus cot square theta. You can write it. And the other application is cosecant square theta minus cot square theta. Cosecant square theta, cot square goes to the other side, gives you 1. So the same identity can be used in 3 different ways. That is what you should learn before working out the other sums in this exercise. Same identity we are using in 3 different ways. Wherever it is applicable, correctly you should judge and then apply in order to get the correct result. So thank you children. I will see you in the next session.